Okay, so let's look at topic 1.6, linear systems. So a system of linear equations is a set of two or more equations using the same variables. And of course, the solution is going to be the set of all ordered coordinates that simultaneously make all equations in the system true. We saw that yesterday when we were looking at that SAT problem. We had the three equations and we were looking for that point where all three equations intersected. So we're going to do this algebraically, and we're looking for the solution of the system of the linear equations right here. I'm going to show you two methods. You can pick whichever one you want to use. They both work. So the first method, this is the one that is shown in the textbook. We're going to solve by setting the equations equal to each other. So what you want to do is you want to isolate one variable. It doesn't matter if you choose X or Y. Choose whichever one is easiest. Now I'm looking at this and I see that I don't have any coefficients in front of these X's. They're already positive. This is going to be nice and easy because all I'll have to do is subtract the 2y over here, and on the second one I will have to add 2y. So let's do it. So here we go. Step one, we're going to solve both equations for one variable. I have x plus 2y equals 3. Subtract the 2y from both sides, and I get x equals a negative 2y plus 3. Take the second equation. X minus 2y equals 4. And I'm going to add 2y. And I get x equals 2y plus 4. Now, we know x equals x. So we can go ahead now and say, well, then if x equals x, negative 2y plus 3 has to equal 2y plus 4. And now notice we are down to one variable, and as long as we're down to only one variable, we can solve that easily. 2y plus 4. So I'm going to go ahead, let's add 2y to both sides. And I get 3 equals 4y plus 4. Subtract the 4 from both sides. And I'm going to get negative 1 equals 4y. And then I'd have to divide out that 4, and I'm out of room. So that means y equals a negative 1/4. So I solved for y. I got that y value, but I need my x. But now as long as I have the value for one variable, I can come back up here. I can choose either one of these equations. It does not matter which one you choose, and plug in y equals negative 4, solve for x. Let's grab the top one. We will do, so we're grabbing this, the first line, x plus 2y equals 3. Substitute y equals negative 1/4 in for y. We get x plus 2 times negative 1/4 equals 3. And now let's simplify. So we get x. This is going to be a minus. I've got a negative times a positive. So this would be a negative 2/4. You could also think of it as cross reducing here. 2 goes into 4 2 times, so I'm left with a negative 1/2. Okay, so I have to add 1/2 to both sides. And I'm just going to squish it over here. So we now have x equals 3 plus 1/2. If I'm going to add fractions, I have to have a common denominator. So I need this to have a 2 in the denominator. So if I do that, I also need to multiply the numerator by 2. So I get 6 halves, and 6 halves is 3, so they are equivalent. And then we get 6 plus 1 is 7, and then halves. So I now know x equals 7 halves. So now let's go ahead and check our work, and then we'll list this as an ordered pair, the solution as an ordered pair. So we're going to check our work. So what you're going to do is you're going to substitute what you discovered for x and for y into both of these equations to make sure you come out with a true statement. So here we go. We get x plus 2y equals 3. X is 7 halves plus 2 times my y was a negative 1/4 equals 3. Well, this is 7 halves. 2 times negative 1/4 is a negative 2/4, which is a negative 1/2. Does that equal 3? 7 halves minus 1/2 is 6 halves. And as we keep reducing here, we get 3 equals 3. So this is true. So it worked for that equation. Let's double check and make sure it works for the second equation. My second equation is x minus 2y equals 4. X minus 2y equals 4. And now again, plug in 7 halves for x minus 2 times negative 1/4 is my y. Does that equal 4? 7 halves. This is now going to become positive, so this is going to be a positive 1/2. Does that equal 4? 7 plus 1 is 8, so we have 8 halves equals 4, and 8 divided by 2 is 4, and ta-da! That is true. So that means the solution is the ordered pair 7 halves and negative 1/4. Do we have any questions on that one? Okay, I'm going to go ahead and stop the recording.